Have you ever wondered how your operating systems in your laptop or desktop computers store your passwords? Clearly, they wouldn't be storing your passwords in the clear text format. Rather, they will compute the hash value of your password and only store the hash value in the operating systems. Let's look at how this works. Since there are different kinds of operating systems, there are different ways of generating password hash. In this lesson, we will look at how Unix operating system compute the hash of your password and how Windows system compute the hash of the password. In Windows systems, there are two kinds of password hash scheme, LM hash and NT hash. LM hash is old and NT hash is new. We will first look at Unix password hash. Unix password hash is computed by using a crypt utility function that comes with the operating system as follows. Firstly, it will encrypt 64 blocks of zeros in DES using your password as an encryption key. Here, one thing to take note is if your password is too long, it will be truncated to make sure that it becomes 56 bits because that is the requirement for a DES key. On the other hand, if your password is too short, it will be now padded with some leading zeros to make sure that it has, again, 56 bits. So once you encrypt that, you will get a ciphertext. Let's call it #1. In the next step, the resulting ciphertext is used again and encrypted in DES by using your password as encryption key again. And then this process is repeated a total of 25 times. So essentially, you are simply encrypting initially a block 64 big blocks of zeros by using the password, and then the resulting hash value is encrypted again and again until there is a total of 25 times of encryption by using your password every time. And that is called Unix password hash. Next, let's look at Windows password hash. Windows have two kinds of password hash scheme, LM hash and NT hash. LM hash was used in the earlier versions of Windows until Windows XP. But from Windows 2000 to Windows XP, both versions were used, LM hash and the new version NT hash, because of the backward compatibility, to make sure that your Windows operating system is compatible to earlier versions of Windows. But after Windows Vista onwards, only the new method, NT hash, has been used. If you want to know more details, you can look at this website. But now let us look at how LM hash and NT hash are computed. LM hash. First step, password is converted to uppercase only. Second step, if your password is too short, it will be null padded with zeros. Or if your password is too long, it will be cut, or also called truncated, to make sure that it becomes 64 bytes. 64 bytes. And then this 64 bytes is split into 7 plus 7 bytes, 7, 7. Later we will see, in the next step, we will see why do we need to split into 2, 7, and 7 bytes. So the first 7 bytes is used as a DES key. Again, that is a requirement of DES. DES require 56 bits key. So 7 bytes is equivalent to 56 bits. right? And next, the second 7 bytes is used as DES key number 2. And we use DES key 1, the first key, to encrypt this string, this literal string, which has 64 bits, and then it will get a ciphertext C1. Next, it uses the next key 2 to encrypt the same string, the same literal strings, this one, which has 64 bits, and you will get a ciphertext C2. Finally, it concatenates the C1, ciphertext C1, and ciphertext C2, and the resulting value, hash value, is called LM hash, which has a total of 128 bits. 64 plus 64 is 128 bits. And that is called LM hash scheme. Again, you don't need to memorize these steps involved, but when you see such steps, you need to understand how things work. All right, let's discuss what are the weaknesses regarding this LM hash scheme. First of all, passwords are not case sensitive. Remember that whatever your password is, it is converted into only uppercase. Second, the passwords are split into 7 characters because 7 bytes. Each byte is equivalent to 1 character. So if you are splitting into 7 bytes each, it means no matter how long your password is, it will only end up with 7 characters plus 7 characters. So in fact, 7 characters, brute forcing 7 characters is considered not very difficult. It is trivial. So assume that you are using only alphabets, which has the range from A to Z. So no matter whether you are using uppercase or lowercase, it doesn't matter anymore, because after all of them will be converted into an uppercase. And then since the scheme is splitting your password into 7 bytes and 7 bytes each, the possible combinations is only 26 to the power of 7 plus 26 to the power of 7. Instead of 52, which 52 means considering both lowercase and uppercase, and to the power of 14 in the case that it did not split into 7 bytes each. Okay, but since LM hash is splitting your password into 7 bytes each, the possible number of combination is only this. So this makes brute forcing trivial. So overall, your passwords are in fact limited to a maximum of 14 characters in length, and that is considered weak. So then in the new versions of Windows, it introduced an anti-hash scheme, which is considered more secure. But this scheme is rather straightforward. In fact, it simply computes a hash value or password by using this MD4 method. MD4 is one of the earlier hash function that we discussed this in the lecture about integrity. All right, so that was about the different password schemes you've used by different operating systems. And if you're wondering about what about the web servers, okay, do they also store the password in a hash format? The answer is it depends. It really depends on the developer who built the website. But nowadays, the typical way of storing your password is the hash format. But what kind of hash function they apply, it really depends on the web developers who built the website. With this, I will conclude the lecture here before we proceed into the lecture on strong authentication methods. Until then, see you next time. Thank you very much.